right, so in this lesson, I'm going to cover the third method for solving these linear systems or systems of linear equations. All right, so far we've done solving by graphing, where you draw the two lines and you look at where they intersect. The last lesson we solved by substitution, where you took one of the variables in either one of the equations, isolated it, and plugged it into the other one. This third method is called elimination. All right, so yeah, so I'm going to jump right into this into this example here. All right, so here's a system. All right, 3x minus 4y equals 7, 5x minus 6y equals 8. All right, so for this method, what we actually want to do here is we want to multiply through such that multiply through by the same number for each of these equations, such that the coefficients, or in other words, the numbers in front of the x or the y are the same, or same but opposite signs. So anyways, it's going to be a lot easier when I actually just do it for you. All right, so for example, if I have 3x and 5x, my lowest common multiple between 3 and 5 is 15, right? So what I can do here, or what I will do, is I'm going to multiply the top one by 5. And then I'm going to multiply this bottom one here by, instead of 3, I'm going to multiply it by -3. So the reason I want to multiply it by -3, and you'll see in a second, is that I'll get -15x here, and I'll have positive 15x up top. Right? So I want the numbers to be the same, but I want the signs to be opposite. All right, so the way that's going to look here up top, right? 5, if I multiply each one of these here, or each one of these terms by 5, I get 15x minus 20y equals 35. Okay, so we got to multiply each one of these terms by the same number. Now in the denominator, or in the second one here, if I multiply through by -3, I'm going to get -15x. -3 times -6y is positive 18y. That's going to equal -24. All right. So the key thing here is I want the numbers in front of the x's to be the same, except I want them to have opposite signs. Now the reason for that is because in our next step, what we're going to do is we're going to kind of like add each one of these columns together. Well, 15x minus 15x is 0. And then -20y plus 18y is -2y. And this is going to equal 35 minus 24, which is 11. All right, now I wrote the 0 here, but we don't actually need a 0 because 0 is nothing, right? And 0 minus anything is itself. So what you'll find is, yeah, maybe it's easier to see if I just did this. These cancel out, and there's a 0 there. All right, so we're left with this kind of simple equation here to solve. -2y is equal to 11. So what I'm going to do here is to solve for y, I'm going to have to divide both sides by -2, such that these cancel. And then y is going to equal or 11 over -2, which is -11 over 2. All right, so that's the value of y. I promise you, if we did substitution, you would get the same value. All right, this is just a different method. Now to solve for x, we actually have a couple options here. What I'm going to do is I'm going to do elimination again. Right? So let me just write this system up again. So I got 3x minus 4y equals 7. And then 5x minus 6y equals 8. All right, so this time, if I want instead of the x's canceling out, I want the y's to cancel out. I'm going to have to multiply the top one here by, well, 12 actually is the lowest common multiple between these. So I can multiply top one by 3 and the bottom here by -2. Right? Again, the reason I want to choose -2 is that I want positive 12y here, whereas I want to leave the -12y up there. Okay. All right, so when we do that, up top we got 9x minus 12y equals 21. And on the bottom one here, we got -2. We're going to multiply each one of these by -2. So that's negative 10x plus 12y equals -16. All right, so I just want to double check that. Right, multiply each one of these by -2. So negative 10x plus 12y equals -16. All right, so now if I was to add up the columns here, 9x minus 10x is -x. Negative 12y plus 12y, well, these will cancel each other off. So this is going to equal 21 minus 16, which is positive 5. So if negative x equals positive 5, I can divide both sides by -1. So that x is going to equal -5. Okay, so that is my solution for this system. All right. So again, x is -5, y is -11/2. All right. And just to check, yeah, I'm gonna, I'm gonna use Desmos, and we'll check this by graphing. The other way you can check it is you can plug these in for x and y into each one of these and make sure it's, the left side equals the right for both. So that works as well. But anyways, I want to use Desmos. So let's just here. All right, so let me just copy and paste the first equation. Let's do the same for the second. And where do they intersect? Let's scroll down here. So you see the red line and the blue line will intersect around here somewhere. All right, so it says it intersects at -5, -5.5, which is -5 and -5.5, right? 11/2 is 5.5, 5.5. So it's been confirmed graphically. All right, cool. So that is actually the only example for this lesson. Share.